It won't be. Alright. Okay, so Thursday we went about the x-axis, we went about the y-axis. Now we're going to go about lines that aren't axis. Okay? We're still going to use the same concept. We're still talking about 2 pi RH times the thickness. However, now we're talking about rotating over a line x equals a or y equals a. Okay? Everything's going to be the same concept. The only thing that's going to change is our radius. We will talk about how that works. Probably already have this picture. Okay, so here's this picture again. There's my little shell inside. Okay, let's talk about the radius. When we had something like this, our radius was y, because the distance from our rectangle to where we were rotating the axis is just y away. Okay, well in this picture, we're talking about where our axis of rotation is to our rectangle. Okay? So if we were rotating about the x-axis, our radius would be from the x-axis to any of our shells, and that would be x. Right? Well, now our line is x equals a in this picture. So how long is this radius? A. Okay. What was this distance right here? And what is this distance right here? A. So what's the difference? A minus x. Okay? Now, what would happen if our axis of rotation was on the other side? Okay? Then we're talking about going from the, then we're talking about x minus a because we're still going from that right to left.
So, if the function is, so where it starts, if it's
okay, if we're on the positive side of the axis, we're talking about a. What?
Wait, how do you know when to flip them around? Whether it's a minus x or x minus
If a is positive, a minus x, because we're going from right to left.
Okay.
But if we're on the negative side, if our function is on the right side, then that function has to come first, so then we're talking about x minus a.
Okay. So from right to left it goes axis then function.
So if we're rotating like this, okay, this distance is x, this distance is r. Hold on. So then we're talking about a minus x minus a negative a, so you're actually going to be adding this, right? X, like if this was negative 4, it would be x plus 4. You see that? Because this distance is x, and this distance is 4. Yes?
So,
X-axis to our
Okay, so it's almost like the function is
So,
Because if you send it forward,
mhm. And so then it becomes,
so the negative that is absolute value of this
right, it's kind of that absolute value, but we don't know how to integrate an absolute value, so it has to become like that 4 plus x.
how to integrate it.
Right. Okay. And we'll do an example of each. Okay, so don't panic. All right. The height of our cylinder, does that change? No, we're still going to have our top function minus our bottom. Okay. Let's remember that. Okay, our radius is going to be our line minus it. Write it down. 4 minus x squared and x 0 and y equals 0. I'm not sure why the problem. And we're going to go about x equals 2. Four minus x squared, what does that look like? Upside down parabola shifted. Okay, and if I'm talking about x equals 0 and y equals 0, that's restricting us to where? The first quadrant. Now, we are going to twist about x equals 2. So here is my parallel rectangle, which means we're integrating with respect to x. Yes. I said x. Now, we know we have 2 pi r8 times thickness. So let's talk about the radius. That's the tricky part. Okay? What's the distance from my rectangle, any given rectangle, back to the x-axis? X. Alright? What about the distance from my line of rotation to the x-axis? Okay, it's 2. So if I take right minus left, we have that 2 minus x. How tall are my rectangles? And our limit of integration? 0 to 2. That's what we do.
How did you get 2 minus
X because I want to know the distance right here. Okay? So if I go from right to left, the distance from here to the x-axis is 2. The distance from here to the x-axis is x. So 2 minus x. Okay.
So if we're red, with the red function, then
Which we're going to look at right now. Yeah. Yeah. Thank you. Okay, so 3x minus x squared. Oh, we are making a bunch cake. That's fun. Isn't there a place called Nothing Bunch Cakes? Clever, right? Okay. So 3x minus x squared. It is a parabola opening which way? What are the zeros? X-axis and this guy. So there's our region, right? Okay. Now we're going to twist this around. X equals -1. And there we have our bunch cake. Okay, awesome. Go ahead and draw in my rectangle. We want to use the shell method in this section. So I have those parallel rectangles. We have thickness dx. Okay, so we have 2 pi r/h times the thickness. Let's talk about our radius. Okay, our distance from any of our rectangles to the x-axis is how far? X. But then we have an additional 1, right? So we have this distance right here, plus we have this distance right here. So you can think of this as x minus -1, or you can think of it as it takes us x to get to the x-axis, plus we have 1 more unit to get to that axis of rotation. Okay, however you would like to think about it. Okay, does anybody have questions on how we got x plus 1? This distance is x minus -1, or this distance is x, and we have an additional 1 unit to get to that axis of rotation. Alright? What is the height of each of those rectangles? If you were doing it by hand, you would multiply those out, but in the calculator, you're just going to type it in. Okay? A majority of these problems on the AP test will be calculator. You will have some without a calculator, okay? And that's why tomorrow will be important. When's the best time to use the shell? When's the best time to use the bit? Thank you. We would go from 0 to 3. We probably need that, won't we? All right, any questions? You guys weren't really sure about the x minus the radius in the beginning. Is this picture making sense? Okay. Another one. Okay. So x equals y minus 2 squared. parabola. Now, since the 2 is with the y, this doesn't move.
Oh, yeah.
Right,
And we have y equals x, right? So there is our region. I'm going to go ahead and erase this so we can just see what that region is. Okay. Let's talk about, first of all, what are our points of intersection? How are we going to find these bad boys right here? Okay. So we have y minus 2 squared equals y. What's y minus 2 squared? So now we have y squared minus 5y plus 4. I can't hear anybody. Okay, so here we're at y equals 1, here we're at y equals 4. Okay, that helps us with our limits of integration, right? We want to rotate about the line y equals negative 1, which is right here, which, looks like this. That is not right, is it? Does it need to go down one more? Yeah. Okay. So we have these parallel rectangles with thickness dy. Alright. Now I want to kind of touch on the washer method right now. If we use the washer method and we had these perpendicular ones, what would be the problem? We have two different sections because top to bottom here is different than top to bottom here. Okay, so this is an example of a shell method problem, or a rotation problem that is best with the shell method because of that. Okay, so 2 pi r8 times the thickness. We know our limits of integration are 1 to 4. Let's talk about the radius. Okay, here's my x-axis right here. So what's the distance from each of my rectangles to the x-axis? It's y. But my radius goes to here. So from here to the x-axis is y. But how much further do we need to go? We need to go one more unit. So our radius is the y plus 1. And what is the height of each of our cylinders? Which one's on the very right? Y minus our left function is the y minus 2 squared. Because our rectangles, okay, this is our height, right? And so remember, anytime we're finding length, we're talking about right to left. So y is on the right and the parabola is on the left. Any other questions? I'd like to give you time to start your homework. So if you have any issues, you can chat. Okay. Now, tomorrow, we're going to go over situations. When is it best to use which method? When does it even matter? Okay, because there's going to be times where it doesn't matter. On Thursday, we're going to have a quiz. Now, some of you are going to have an assembly at 9 o'clock because you have a 4.0 or higher GPA on the weighted scale. Okay? You are still taking the quiz.
At 9 o'clock, you said it's the assembly?
It starts at 9. I'm hoping it's going to be done by 10. I don't really know. But you're still going to be responsible for the quiz. So we'll see what time you get out. We'll see how long it takes to take the quiz. And then we can adjust our time from there. Okay, but you will be taking the quiz on Thursday. Okay? Hopefully I'll have more information tomorrow on how long it actually will be. Okay? I want everybody to look under their desk. There are some floating calculus books. I don't really think I have very many extras. Calculus books. If your calculus book is under your desk, please say it will be. Maybe there's one. Is that yours? Is that anybody's in the pod? Everyone has their book? Okay. I know I don't have 4 extra. I don't know if people don't get their names in. I'm not your locker, so if it's yours, take it. I won't be mad at you anymore.